Hello students, myself Dr. Ankit Kumar. I am assistant professor in the Department of Mathematics, School of Computer Science and Artificial Intelligence at SR University. So today I will discuss about the Poisson distribution, its application, where it is used, its limitations, and what is the difference between binomial and Poisson distribution. After that, we solved some numerical problems. So we just proceed. So what is the binomial distribution? A discrete probability distribution. This is a discrete probability distribution. So first thing is noted. Modeling the number of events in a fixed interval. Okay. Given a constant average rate. So first point is discrete probability distribution. This is a discrete probability distribution. We evaluate each event on each point. Okay. A specific point x is equal to 0, 1, 2, 3, 4, and so on. So this is a type of discrete distribution. And it is modeled on the number of events in a fixed interval. There is always a time interval is given. Time interval is given. So if time interval is given, then you apply the Poisson distribution. And a constant average rate of happening an event is also mentioned in the question, and it is known as, okay. So these three things are given. So if x follows the Poisson distribution, with parameter lambda. So there is only one parameter known as lambda. So what is the probability mass function? Probability mass function of Poisson distribution is given by lambda e to the power minus lambda to the power k upon factorial k, and this is equal to px is equal to k, not r. So here r is x is equal to k. So lambda is the average rate, average number of occurrence of an event. K is the how many number of success or failures occur in any experiment. Number of success or failures. Number of success or failure occur in any outcome. Occur in any experiment or event. And is the Euler's number which is having 0.2.17828. So if we read the question, there is an event happening in a specific time interval and in a specific time duration, and the average number of the happening and event is given. You just apply the Poisson distribution. So in the question, lambda is mentioned, time duration is mentioned, and they will ask for how many number of success or failures occur in a particular time interval. So we apply this Poisson distribution. So here we also one thing mentioned that k goes from 0 to 1, positive integers. It takes 0 to 1 to 3. Okay, so px is equal to 0 means if we put 0 in this formulas, then lambda is 0, e to the power minus lambda, and k 0 factorial. So this becomes e to the power minus lambda. Okay, so this is if we put 1, 2, 3, then this formula is you evaluate for each of the k. So what is the key characteristics? Key characteristics is that this is a discrete type of the probability distribution. So the number of events can occur only a whole numbers, means 0, 1, 2, 3, not a fraction, not a negative integer. Fixed interval means it applies on a fixed duration of time, area, volume, or some time interval. The occurrence of one event does not influence the occurrence of the other events, meaning the occurrence of one event is independent of the occurrence of the other event. Constant rate, the happening of an event, the happening of an event is the happening of an event is constant. Okay, so this is also a very important point. So all these three key characteristics which is used in the Poisson distribution. So common use means customer service. So first of all, we discuss about the predicting the number of customer service calls or customer request per hour. Per hour, how many customers are arriving in a particular restaurant, or how many number of calls received by a company, and how many number of the phone calls received by the manager. So there are some criteria, some customer service application are also used in Poisson distribution. Quality control means how many number of defective items produced by a machine, or how many number of defective products produced by a manufacturing company, or how many numbers of defective pages printed by a machine, or how many numbers of error in a page. So these things are also covered in quality control. So if there is a quality control, then we apply the Poisson distribution. Nature disaster means the number of lightning strikes or earthquakes in a given year, means this is a time duration year. Number of the accident occurs in a week. Okay, so so how many number of disasters occur in a particular year or particular month or particular time? So if these things are happening in the question, then we apply the Poisson distribution. Finance related problems such as analyzing the number of default or transaction in a given specific period. So how many number of default transaction in a specific period occurs? So we analyze this. We use this Poisson distribution. So these are the some criteria, some common uses in which we apply this Poisson distribution. So this is the application part. How binomial distribution based Poisson distribution? So this is K. This is formula NC K p to the power K 1 minus p to the power K. So here the things are required is X follows if binomial distribution, if X follows the binomial distribution with parameter n and okay. So n is the total number of outcomes, p is the probability of success of an event. So total number of event are given and the success of one event, the probability of success of one event is given. So using these two, we evaluate how many k number of success of events. Okay, if one number of success of probability is given, there are n numbers of events occur, then then the probability of k number of success is produced by the binomial distribution. And the mean of the binomial distribution is NP, variance is NP 1 minus P. What is the assumption? So the assumption is that fixed number of trials occurs, two possible outcomes occurs, independent trials and constant probability. So these are things. Example, we have already discussed in the previous video. That is, if a fair coin is tossed 5 times, then what is the getting of exactly 2 heads? Meaning thereby, if we toss a coin, then probability of getting a head or tail is fixed. That is 1/1. So these are the assumption. There's the occurrence of an event is fixed. All the events are independent. There is happening of an event is constant. Okay, there is no changes. So these are the criteria of the binomial distribution. What is the Poisson? In number of trials in binomial distribution is fixed n. but in number of trials in a Poisson distribution is not fixed. It is unlimited. It is unlimited. Px is equal to k. The formula of Px is equal to k is e to the power minus lambda, lambda to the power k upon k factorial. So this is the formula. Okay, R is the number of events that occur. Mean is lambda, variance is lambda square. Variance is lambda. So this is the distribution in which mean and variance both are the same. What is the assumption? That in this type of the assumption, probability of success is very small. Number of trials is large. Means remains constant. So if there is n is equal to 100 and p is equal to 0.1, this is also a criteria for applying the Poisson distribution. And the value of n is large and the value of p is very small. And means remains constant, meaning thereby the average rate of happening an event is constant. So a call center receives an average of 3 calls per minute. The probability that exactly 2 calls arrive in a minute, what is the probability? So 3 calls per minute, that an average 3 calls per minute means lambda is equal to 3. Average. Lambda is nothing but average per minute. So probability of exactly 2 calls means p x is equal to, so you just put e to the power minus lambda minus 3, lambda 3 to the power 2 upon 2 factorial. So this is the answer of this question. Okay, now we forward discuss the further questions. So a bakery receives an average of 4 customers. Average means lambda is equal to 4. Average 4 customer every 10 minutes. What is the probability? Exactly 6 customer in 10 minutes. So lambda is equal to 4 is given. What is the, if capital X denotes the event that n number of customers arrives. Okay, so lambda is 4 given, x denotes the number of events that n number of customers arrives. So what is the probability that 6 customers arrive? If x is equal to 6, then what is the probability? So e to the power minus, what is the formula? Px is equal to k is e to the power minus lambda, lambda to the power k upon k factorial. So 6 is k. So e to the power minus lambda is 4. 4 is given. So e to the power minus 4, 4 to the power k. K means 6 upon 6 factorial. So if you evaluate this, you find value. E to the power minus 4, 4 to the power 6 upon 6 factorial. So you can elaborate this. E to the power minus 4, 4 to the power 6 upon 6 factorial, 6 cross 5 cross 4 cross 3 cross 2 cross. So you just solve by calculator. What is the value of E? E is 2.7183. So what is the E? What is the value of E is 2.71828. 2.78 to the power minus 4, 4 to the power 6 upon this is 7. So if you solve, then it is given 0.104. Okay. So lambda is given and 6 customers arrives in 10 minutes. What is the probability that exactly 6 customers arrives in 10 minutes? So in this question, first read the question 2 or 3 times, very good. The average number of phone calls minute coming per minute. Average number of calls per minute coming into a switchboard between 2 to 4 p.m. means this is time duration is given. Time duration is given. is 2.5. So lambda is 2.5. Okay. 4 or fewer calls. 4 or fewer. 4 or fewer. So this is 4 or fewer means I is equal to 0 to 4. Px is equal to I. So Px is equal to 0 plus Px is equal to 1 plus Px is equal to 2 plus Px is equal to 3 plus Px is equal to 4. Okay. And what is the formula? You also written the formula here is Px is equal to K. So Px is equal to K formula e to the power minus lambda, lambda to the power K upon K factorial. Okay. So you write for each of one x is equal to 0. So we put in here x is equal to 0. So e to the power minus 2.5 to the power 0 upon 0 factorial plus e to the power minus 2.5 to the power 1 upon 1 factorial plus e to the power minus 2 or minus 2.5 to the power 2 upon 2 factorial plus e to the power minus 3 to the power 2 upon 2 3 we have related for 3. So e to the power this is e to the power minus this is e to the power minus lambda means 2.5 and 2.5 to the power 3 upon 3 factorial plus x is equal to 4 e to the power minus 2.5 to the power 4 upon 3 factorial. So if we evaluate these things by calculator, we are done. Okay. So here it is written here. You can evaluate Px is equal to. Now, more than 6 call. More than 6 means Px is greater than 6. So how we evaluated 1 minus P? How we evaluated this? We see here. So if Px is greater than 6 is given, how we evaluated? It assumes value 7, 8, 9, 10, 11 up to infinity. So if we minus P summation I is equal to 0 to 6 because it contains more than 6. So we subtract the value 0 to 6 from 1. We find the value, required value x is equal to. So this is 1 minus Px is equal to 0 plus Px is equal to 1 plus Px is equal to 2 plus Px is equal to 3 plus Px is equal to 4 plus Px is equal to 5 plus Px is equal to 6. So if we evaluate for each event, then we are done. So here we calculated for 0, 1, 2, 3, 4. Okay. So you just use the value 0 up to 4. Okay. Up to 4 from part A and you evaluated only 5 and 6. So you are done. So you find the value of 0.01416. So I think you evaluate this one because Px is equal to 5, Px is equal to 6. So we are no problem. We just solve one. No, 1 minus P. This given is x is less than or equal to 4 is 0.8912 plus up to 4 it is given up to 4. This is up to 4 it is given. We evaluate x is equal to 5 and x is equal to 6. So x is equal to 5 means e to the power minus 2.5 to the power 5 upon 5 factorial plus e to the power minus 2.5 to the power 6 upon 6 factorial. So if we solve these things, we get the required answer 0.014. Okay, so this is the solution. Now, this question is given. A factory produces electronic components and the number of defective components found in a quality control check follows a Poisson distribution with an average of 3 defects per hour, means lambda is equal to 3 defects per hour. What is the probability that in a given hour exactly 2 defects components are found? So what is the formula? P x is equal to k, means e to the power minus lambda, lambda to the power k upon k factorial. So p x is equal to 2, exactly 2. Exactly 2 means e to the power minus lambda is 3, 3 to the power 2 upon 2 factorial. So you just evaluate. What is the probability that in a given hour at most 2? At most 2 means px is less than or equal to 2. So px is equal to 0, px is equal to 1 plus px is equal to so you just evaluated x is equal to 0 means e to the power minus 0, e to the power minus 3, 3 to the power 0 upon 0 factorial, e to the power minus 3, 3 to the power 1 upon 1 factorial, e to the power minus 3, 3 to the power 2 upon 2 factorial. If we add all these things, we get the required answer. At least 10. What is the probability? If the quality control team inspect for 4 hours, 4 hours. So in this question, lambda is given for 3 defects per hour. 3 defects per hour. But here given 4 hour. So lambda is 3 into 4. So 12 per hour. This is converted for option third. Lambda is 12 per hour. So at least 10 defective items. They ask for at least 10. Px is greater than or equal to 10. So how we solve this? We see in next slide. So here they written this. So if they ask for px is greater than or equal to 10. So means it assumes the value 10, 11, 12, 13, 14, 15 up to infinity. So if we minus p iota is equal to 0 to 9, p x is equal to I. So this becomes 1 minus p x is equal to 0, x is equal to 1, x is equal to 2 plus up to x is equal to 9. If we evaluate each probability using the formula px is equal to k e to the power minus lambda, lambda to the power k upon. So if we solve using this formula, evaluate for each 0, 1, 2 up to 9 and add all of them and subtract from 1, then you get the required answer px is equal to. Now there are some practice problems, we just solve them. So a telecom company operates a 24 hours customer support call center. From past records, the manager observed that the center receives an average of 4 complaints per hour. So lambda is 4 complaints per hour. No complaint is received. 4 lambda is equal to 4 complaints per hour. So this is lambda. No complaint means px is equal to 0. What is the formula? Px is equal to k means e to the power minus lambda, lambda to the power k upon k factorial. X is equal to 0 means e to the power lambda is 4, e to the power minus 4, 4 to the power 0 upon 0 factorial. So first question is done. Exactly 3. So px is equal to 3. So x is equal to e to the power minus 4, 4 to the power 3 upon 3 factorial. So second part is done. Now we go at least 2. So px is greater than or equal to 2. So this is 1 minus summation I is equal to 0 to 1. Px is equal to iota. So this is 1 minus px is equal to 0 plus px is equal to 1. So this becomes 1 minus px is equal to e to the power minus 4 to the power 0 upon 0 factorial plus e to the power minus 4 to the power 1 upon 1 factorial. 1 factorial. So if we solve this, we find third part. Now we solve question second. An e-commerce website experiences occasional server failures during the day. Based on the last few months of data, the technical team found that the website records an average of 2 server. Average means lambda is this is the here we solve. So lambda is equal to 2. Determine exactly one failure means px is equal to 1. E to the power minus 2, 2 to the power 1 upon 1 factorial. So this is first part. More than 2 failure means we solve this here. Px is more than 2. So this is 1 minus eta is equal to 1 to 0 to 2. Px is equal to eta. So 1 minus px is equal to 0 plus px is equal to 1 plus px is equal to. So if we put all these values, so this becomes 1 minus e to the power minus 0, e to the power lambda. Lambda is 2. So e to the power minus 2, 2 to the power 0 upon 0 factorial. E to the power second, x is equal to 1 part. So e to the power minus 2, 2 to the power 1 upon 1 factorial plus e to the power minus 2, 2 to the power 2 upon 2 factorial. This is for this and this is for this. If we solve this identity, you get the required answer. No failure. This is B part. This is A part. And here we solve. No failure means Px is equal to 0. No failure. E to the power minus 2, 2 to the power 0 upon 0 factorial. So this is C part. Okay. So I think this is solved for each cases. Now, there are third and fourth problem also. So we just solve third problem and there is homework for question 4 you solve easily. So 0.5 printing errors per page means lambda is equal to 0.5. A no error means px is equal to 0. So e to the power minus lambda, lambda to the power 0 upon 0 factorial. So this is a part. Exactly one error means b is equal to px is equal to 1. So e to the power minus 0.5, 0.5 to the power 1 upon 1 factorial. This is answer 1b. At least 2 error. Px is greater than or equal to 2 means 1 minus px is equal to x is equal to 0 plus px is equal to. So if you put all these values, you get the answer for this. Now we solve last one also. So there are 3 accidents per week is given. So lambda is 3 accidents per week. A part exactly 2, px is equal to 2 means e to the power minus 3, 3 to the power 2 upon 2 factorial. B part, no accidents means px is equal to 0. So e to the power minus 3, 3 to the power 0 upon 0 factorial. And C part, more than 3, px is greater than 3 means 1 minus p I is equal to 0 to 3. Px is equal to eta. Greater than 3 means if we subtract 1 minus this, px is equal to 0 plus px is equal to 1 plus px is equal to 2 plus px is equal to 3. Okay, if we evaluate all these probabilities 1, 2, 3, then we get the probability greater than 2, 3. So we just 0, 1, 2 for each probability and we get the required answer. So I think you solve all these problems very carefully. So I will summarize once again. Summary. Summary is What is the probability mass function of discrete Poisson distribution? E to the power minus lambda, lambda to the power k upon k factorial, where lambda is average rate, E is nothing but 2.71828, k is number of success or failure. And it is applied on the time interval or time duration is given in this question, and it is also applied when n is large and p is. So these are the necessary things you can remind in your mind. So at last I will request you to all of you kindly like this video and subscribe my channel. So thank you very much.